All right, let's go over our Super 6 cholesterol and exercise problem. So, we were first asked to explain how you would carry out a completely randomized experiment, meaning not blocking by a particular trait. So, that's what we did with StratMeCap. Start with the subjects that you have. And so, we start with the volunteers that we recruited for this study, randomly assign them with a big bag. So randomly assign them to the treatments by, and then now here's the asterisk, is that shake, 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 do 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 do, shake, 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 shake your bag up. So shake them by putting the names in a bag. Shake well and pull out. I don't know how many volunteers, so I'm saying half of the volunteers for each treatment. And treatments, state your treatments very well. Treatment groups are the new cholesterol reducing drug and the current available cholesterol reducing drug. So that was our control group, is what's currently on the market. Control does not have to be a placebo. Measure each subject's response. So here you are telling me specifically what response is being measured. Measure each subject's cholesterol reduction. And I said after minus before. So basically, I'm seeing how did I start? How did I finish? And what is that change that I had in my reduction? Compare the average or the proportion. Well, because this, you probably could say this either way, depending on what you want, how you want to look at this. You can either average together all of those reductions and see if there really is an average reduction. So that reduction is a negative number. So the average is lower than before. So it's less, average is less than zero. Okay. Or maybe you did the proportion of patients who had cholesterol, who had reduction. And so then maybe you're comparing the proportion. Now, if you did proportion, then you're really, I mean, what are you comparing that to? 50% who had a reduction and 50% who didn't have a reduction. So that one might be a little bit more awkward. If you did proportion who had, yeah, I mean, what are you comparing it to? 50%. So with this quantitative data, I think it's really more informative if you do this matching, where we're doing a reduction per person and we are comparing it to see if there is an average difference in the reduction of cholesterol, to see if there really is a significant difference in the average cholesterol reduction with the new drug. So here, describe the experimental design, would how you could improve it by incorporating blocking. Well, that they're leading you here because they mentioned that exercise or drug treatment. Well, we just did an experiment with the drug treatment. So here I thought, okay, well, maybe we need to control exercise since that is something that could also affect the cholesterol reduction. So we then would want to block by exercise level. So remember when we would do that, the Babratmi capped, when we would block by this trait because that trait is most impacting the what we are measuring. So I would, since the exercise is the trait that could affect cholesterol reduction, you would first block volunteers. You block first, and then within each block, you do an experiment. So, block the volunteers by exercise. I just chose high and low, and then perform the experiment within each one of those blocks. Can this be carried out in a double blind manner? Yes, it could. You can, and so when you do this, make sure you're kind of indicating the definition in context. So you're stating what it is and how they could do that. Well, and then that's what they're asking you in the next section. How could you actually accomplish that double blinding? And so I said yes, but here's what that means. See, I'm communicating what that double blind means. And that means that neither the volunteers nor the evaluator, the doctor or whoever it is evaluating their blood pressures, would know which drug the patient is receiving. And so, how could that happen? I would make it so that the new drug and the current drug look the same. They're in the same packaging. There's no distinguishing traits so that I can tell the difference from one pill to the other. Um, Also, you can then make sure that you randomly assign the subjects, which we set up above, to put so that half the volunteers get each treatment. What would this be? A two mean t-test. If we were doing comparing the average reduction on the new drug and the average reduction on the current drug. So we would be comparing those average reductions, those two means. And so you get this p-value. Okay, so that means we had evidence. So here, could you then indeed say, yes, it is the new drug that caused, that's what they're going for, that caused this reduction in cholesterol? And that is yes, because it was a controlled experiment with a treatment where we randomly assigned the subjects to the treatment groups. So, therefore, and then since the p value was less than alpha, then we would have rejected that null hypothesis and said, yes, we have evidence that the average cholesterol reduction with the new drug is less than the average cholesterol reduction with the current drug. And you can generalize those results to people like these volunteers. Um, that is a limiting component that we have when we have volunteers. Maybe these are people who are going to be much more conscientious with their health, or maybe even not so because they just want the pill to take care of it all. Whatever the characteristics are, you can generalize to people, subjects who are like the volunteers in this study. Identifying those subjects treatments, factors and levels, that seemed to be the thing that we were wondering about. Volunteers were with a history of high cholesterol who are not currently on medication. It stated that word for word in the prompt. The treatments were those two different cholesterol reducing drugs. The factors, okay, so factor means how many things get assigned to the subject. So in this case, type of drug was the one factor that we had. And how many of those types of drugs were there? That's the levels. There were two levels, the new and the current on the market. And the response that we were measuring was cholesterol reduction. Excuse me. Now they say, hey, when you did this for the exercise, when you did the blocking for the exercise, then how many factors and levels are there? Well, now there's two things. Now there is two, they ended up assigning them to an exercise regimen, high, low level, or not at all. So it wasn't not a natural trait that we blocked by. They randomly assigned to a treatment of exercise as well. So here now there are two factors. Each subject will get assigned either an exercise level with high, low, or none, three factors, or three levels. They will be, okay, two factors. Exercise is one of them, and there's three levels of exercise: high, low, none. Drug type is the second factor, and there are two of those, new and current. That made a total of 6 treatment groups, and I spelled those out: high exercise, new and current; low exercise, new and current drug; no exercise, new and current drug. All right. There was your primarily experimental design idea with the cholesterol, drug, and exercise.